everywhere we have data. Data science is the process of maintaining and managing those data. And machine learning is most interesting topic, and next most interesting topic, how to make the machine to learn by itself. In this session, for the first 1 hour, we can see the application of data science, where and all we can apply the data science concepts. Then in the next 1 hour, how to handle the data, how to classify the data, and how to handle the data. And the last 1 hour, finally it is ended up with data learning by machines using Python. Actually, we framed perfect curriculum for this course. You can check it out in our website also. Today's session and the whole course is carried out by two eminent persons. Let me introduce first Mr. Vijay Bhaskar, Senior Data Scientist, passionate IT professional with 14 years of experience in Python, R programming, SQL, machine learning, deep learning, probabilistic statistics, applied statistics, mathematics, AWS, and IT project management and product management. Next, Mr. Akash Vikram, data analyst and digital marketing lead. He has done his engineering in computer science. Can you hear me? Please, anyone can respond. Can you all hear me? Yeah. Okay. Yeah. Second person, Mr. Akash Vikram, data analyst and digital marketing lead. He has done his engineering from the computer science from IIT. He worked in Amazon as data analyst. He's also having 3 years plus experience in SQL, Tableau, big data, and currently he is doing his business in digital marketing and advanced Google Analytics to track the website links. Before getting into the session, we can give an assurance that by the end of this session, you will have better knowledge in this technology. And one more thing, kindly subscribe our channel to have more videos on trending techs in upcoming days. Once again, we welcome you all. We can get into session. It's over to Mr. Vijay. Mr. Vijay, please carry on.
Thank you, Anita. Am I audible to you all? Am I audible?
Yeah, Vijay. Yeah.
Okay,
very
excellent.
Clear.
Yeah, warm welcome and a very good evening to everyone here. Hi, like Anita had introduced, my name is Vijay. I'm currently working as a senior data scientist. So today's
Vijay, I have to be a little bit louder.
Okay. Am I audible now? Clear? Louder?
Yeah.
Clear? Okay.
Yep. Yep.
All right. Yeah. So our today's session will be on applications of data scientists, data sciences. We will talk about a bit on data, like what are the different kinds of data that we have. And we will also see a bit of Python programming and then how to install Python, why Python. So we will talk about all this important things today in the webinar. So is anyone, a question to the audience here, anyone who is not from a mathematical background, if yes, can raise your hands. Not from mathematical background. All right. So assume that everyone has some knowledge about mathematics, right? Okay. All right. So good. If you have any questions, probably you can raise your questions. We will have a few breaks in between. We will answer back to your questions during the session breaks, right? So this is going to be a little longer session, explaining about different aspects of machine learning and data sciences. All right. So without any further delay, let's get into the webinar quickly. So yeah. So I'm sharing my screen. Give me a minute. I think I need access to share my screen.
Yeah. Give me a minute.
Sure. Yeah.
Yeah, Vijay, I have given you. Please
Okay, sure, yeah.
take over.
Yeah. Okay. So I'm sharing my screen here. Is my screen visible to you?
Yes, yes, clear. We are able to see you. Yeah.
Okay, let me move it to a different computer. Okay. Okay. Excellent. Yeah. So, yeah. So, is my screen, complete screen, visible to you all? Okay. Okay. So, so today's session is on introduction and demo of data science and machine learning, and is this one? Give me hold on a minute. Hold on a minute. I'm just setting it up. All right, so let's jump into the session. So we'll talk about what a data scientist would do on a very high level. What would a data scientist do on a very high level? And then we will see what kind of things, who is a data scientist? And why a data scientist is important in today's, in today's, why is he relevant? We'll talk about that. So data, so as so far you have seen that data scientists are, this domain is exploding with a lot of jobs these days. Why? The question is, the answer to this question is because there is a lot of data available everywhere. Data is available everywhere. In the backend systems, in the cloud computing systems, you have public data sets, private data sets, you have data sets in every sector. Now corporates are interested to take data-driven decisions. So why should corporates take data-driven decisions? So data-driven decisions helps corporates to do future analysis like future, if I can make profits in future, or if my organization fails in future, what should I do? So these kind of important answers are available through data. And since data is available in abundance these days, so data scientist job has become extremely important. And that's why we have a course here about data sciences. So in this course, we will be learning several, this is going to be a very exciting journey with a steep learning curve. So let's get it started. So this is what a data scientist would do, and we have a few roles here out there in the market. We have a software engineer, we have data engineers, and we have also data scientists. Now, what a data scientist would do is, so data scientists would usually have knowledge on would usually have knowledge on statistics, machine learning, somebody who has knowledge on algorithms, statistical modeling, SAS, and there is also a common area where a data scientist should also be knowing the programming, right? So data scientists should also know some amount of programming in C and C++, Python, to some extent, and as well as big data systems to some extent. And he should also be knowing about business intelligence and data analysis. So a data scientist job is extremely critical because a data scientist is somebody who has experience with data. And so to understand what data is, so you need a set of tools. So these are the tools that you use to understand what data is. In some time we'll talk about, we will see what data is, and in the next session we'll see what data is. So till then, you can bear with me to understand, what a data scientist would have, and what would be a day of how would a data scientist, what would a data scientist do on a day-to-day basis? So data scientist would do problem analysis. So a problem analysis is essentially like it can be, there are many problems a data scientist would work on. So it depends upon the area and the domain that a data scientist is working on. If the data scientists are working on products, and if the data scientists are working on services. So the problems vary from products and services. If it is a data scientist who is working on products, then they would be developing data science components, product components for data science components into products. And for services, you have, say, we'll talk about the applications in some time. So some of the service applications which you can integrate. So problems such as prediction problems, clustering problems. This is something that we will talk about in some time. Prediction problems, clustering problems, and then you have regression problems, and then you have reinforcement learning problems. So these are the different problems we typically work on a day-to-day basis on a very high level. So given a problem would be like, I wanted to, you have a customer, and then he has to travel to a destination which is about 3,000 kilometers to a place here. Now, this is kind of a problem that you wanted to work on. So if you have a problem, and then this 3,000 kilometers can be in any direction. It can be from Kanyakumari to, it can be Kanyakumari from Kashmir to Kanyakumari. You have n number of ways, right? So which is the shortest route that a person can travel from one place to another place. So that is a kind of problem. This is an example that I'm trying to give you, like what a problem would be, and this is the kind of a problem which you would be working on. And to work on that problem, what is that you would be needing? You would be needing data. So, but what kind of data do you need? So understanding that for the relevant problem, you would need data. So so should you take news analysis data for this problem? Or should you need video data? Should you need text data? Should you need numeric data? What kind of data do you have? Or what kind of data is available with the customer? So you have to understand the data and select the right data for the problem. So data collection strategies is devised by the data scientist. And once the data is collected, data must be clean. So always the data that is available from different backend systems is unclean, is extremely unclean. So the strategy to clean the data is the onus of the data scientist. So data cleaning strategies must be developed by the data scientist. So what are they? So how do you clean the data? We have a few set of steps to clean the data. We will talk about these data cleaning steps down the lane in the upcoming slides, right? So after the data cleaning steps are devised, what comes next is the solution design. So using the data, identifying different sets of variables with the help of the subject matter experts, a data scientist would develop a solution. The solution would be, it can be a mathematical solution, a mathematical approach to the problem using data sciences. So once the problem solution, it could be a model, it would be a machine learning. Which machine learning model do you apply on the data to to get the right predictions, to get the right clustering, to get the right solution to the problem that was defined earlier. So this is the duty of a data scientist, to analyze it on a, this is an iterative step. So solution design, and then you see if the solution is in relevance with the problem. That is, if the solution design that comes in the next step. That is, you develop a solution, and then if the solution is working or not, you have to iteratively test here. So once you iteratively test here, so your model, you build a model, and this model is ready for deployment now. So once the model is ready for deployment, so the next step would be to deploy the model. Now, once so to deploy a machine learning model, data scientists would work with AWS. Data scientists would work with DevOps teams, and they would also work with data engineers to deploy the machine learning model into test systems and production systems, to see if the solution to iteratively test the solution and the relevant problem. So once the problem is done, now you have new set of data, new unknown data, which is coming from the from the production systems. So you have new data coming up every day, and then so data coming on a day-to-day basis is new data. Now for this new data, again, the model has to be updated iteratively. So you have to check the relevancy of your model once the data is collected. So the data scientist would again check for some time if the model is working right, if the model is working with the if the model is giving the relevant output for the designed for the problem defined. So this is how data scientists would be involved in different stages. Yeah. So this is something about data science. So any questions here that I can take here? Probably I'll take a pause here and take questions from the audience. Hello. Hello.
So guys, any questions? I was hearing a lot of queries during the morning sessions in terms of people who are actually in other technologies, and people who are from completely non-IT background. If you have any specific, it's not about understanding the concept. It's all about, if you have any other specific questions, you can shoot out now at this point of time, because Vijay is actually from a live, he has handled a lot of live projects, right? So if you have any clarifications, whether I will fit in for this role, or if you have any basic questions, feel free to ask. There is nothing, there is no issue on that. Okay, whatever may be an elementary question, that's absolutely fine. Please feel free to ask it actually.
In data clinic, which technique we are used to cleanse the data, sir?
Can you be a bit louder?
Yeah, in data cleaning, how we cleanse the data? If we are getting text data sets from the what we are collecting, how we transfer text into numbers, because with the numbers only we do the analysis, right?
Yeah, that's right. Yeah. So I will walk you through. There's a slide which we talk about on the data cleaning. Probably there are 45 minutes to 1 hour. You will have the answers to your question. We have a set of steps which we define. The set of steps are, probably it is too premature for the other audience, but yeah, to answer your steps, there are a set of strategies. There are about close to 10 to 15 10 to 15 strategies that we apply for cleaning up, for text cleaning. Like if we use regular expressions for cleaning the text. So regular expressions is one of the packages in Python available for text cleaning. There are many other packages in sklearn that we use for text pre-processing. I'll answer to your question when the relevant slide comes up. I'll explain to you in detail. So this is a very high level summary I can give you at this point of time. So if there are no questions, probably perhaps we can proceed. Bhupati? All right.
Yes, sir. You can continue.
Sure. All right. Yeah. Yeah. So this is what we will learn today. We will get to know about why data sciences. What are the components we study in data sciences? What are the areas of focus that we have as part of the course curriculum? And we'll talk about data, and then we will also talk about we'll give a short introduction about Python. So why data sciences? I think we spoke about this during the introductory lecture about why data sciences. Now, data sciences is there are many classical examples that we see on a day-to-day basis about why data sciences. Some of the examples that we see today is about monsoon arrival and prediction. You would have seen that monsoons. You would have seen the predictions to monsoons during the month of April and June, telling about the long-term performance of the monsoon, right? So monsoons begin on 1st June, right? So monsoons arrive on 1st June. So this is by default that we have thought as we have taken it that it arrives on 1st June. But how did IMD, who is the other player, who is the other player who predicts, who does monsoon forecast and prediction? Any answer here? If somebody has followed about the monsoon predictions, yeah, it is SkyMet, right? So SkyMet is a private player, and IMD is a government source that provides monsoon predictions, right? So to predict a monsoon, to predict the arrival of monsoon, there are many things that that experts would look at. They would look at the weather phenomena. They would look at the temperature, global temperatures. They would look at oceanic temperatures, ocean temperatures, right? They would also look at if there is a El Nino, how the El Nino is performing in the Pacific region. El Nino and La Nina effects in the Pacific region. The pressure in the southern hemisphere. So they would look at several parameters at the global level, and then they would arrive at they would pick those data points. And after picking those data points, after reading the data points over a specific amount, over a specific time, over a specific period of time, say probably for 12 months, they would look at these parameters, and then they would arrive. They would say that for the next 6 months, we will have this kind of a weather down the lane, right? So they would start predicting it with a certain amount of confidence. They would provide a confidence level to the data. They would say with 5% error or with 10% error, with 10% error margin. So why why would they provide a confidence level here? So if you look at the weather phenomena, it is always statistical. So statistical parameters are never accurate. So statistical parameters are never accurate. That's why you have a confidence level. You have a confidence level with an error margin. So since statistics is never accurate, you have a confidence level added here. We will talk about this confidence levels when we enter into statistics and when we talk about the inferential statistics about what these confidence levels are. Now, given sampled data for the last 12 months, they would also look at the patterns. They would also look at the patterns for the last 100 years. Since the time the data for the monsoon is collected, that is around 19th century, around 1900s, between 1900s and 2020, right? So you would see different predictions, and then these predictions are cyclic in nature, right? So they would look at those patterns, previous patterns, and they would also look at the global phenomena, and they would arrive at the predictions, right? So this is one of the very good examples that we can see on a day-to-day life about the monsoons. And monsoons are really important for an economy, for the growth of economy. So the complete Sensex depends upon the agricultural forecasts, right? So you would have seen Sensex bouncing up or bouncing back based on the weather predictions. So since India is an agricultural economy, it is very important that monsoon predictions are as accurate as possible, right? So this is one of the applications where we'll see data sciences. And this is a whole big area where you can do significant research if you are planning to become a data scientist. So this is an excellent area. This is an excellent domain where you do, where you can study data sciences for agriculture, right? And climate. Agriculture and climate are very, these are very active areas in data sciences where you can apply data sciences, and you will learn a lot. There are dozens of projects live at this point of time on agriculture and climate. So next comes, okay. So I hope I'm able to explain this concept very well to you. Let's move on and see what is the next application of a data sciences. So we'll talk about customer segmentation here. So what is customer segmentation? Given they have data, they would like to understand. They would like to understand, which areas machine learning is being, how they wanted to increase the number of customers. So corporates usually love to increase the number of customers, because as more customers get added to their systems, they can increase their profits. So if they have more profits, it's more prosperous to the company as well as the employees. So how do you make, so why do you need to acquire customers? You need to acquire customers because you need to provide better products to the customers. So how do you make better products to the customers? So you make better products to the customers based on the customer behavior, based on the region where the customers are coming from, based on the demographics. Like you have college students, right? Based on the gender group, based on the occupations, you can make different products based on their different attributes, based on the behavioral, based on the behavior of a customer. You can make different products based on the psychographic elements of a customer. You can devise different products. So in business parlance, we call it as customer segmentation. So given your data, a data scientist should cluster the data in such a way that you have to should cluster the data in such a way that for geographic regions, how are the customers in these geographic regions what are these customers in these geographic regions are looking for, right? So how are they behaving on an overall at overall at overall on the overall data that you have. So based on the, so how do you do that? You use some of the data science techniques such as clustering to you cluster the data based on these regions. So this is a unsupervised supervised machine learning technique. There are whole bunch of machine learning models which are available here. We will do a deep analysis, deep mathematical analysis for clustering, right? So we'll do a mathematical analysis, and we'll also do we will do a lab. We will also do a lab session on how we cluster the data using Python. And for prediction, also we will look at some of the machine learning algorithms, some classical machine learning algorithms that we have. We will do a mathematical analysis, and we will look at the lab for this, right? So let's move ahead and then look for different. We look at the different applications which are available in data sciences, and why. We'll get to know as we look at more number of applications. We will be able to answer about why data sciences is needed in today's life. Forecasting. So forecasting is very important. Where did you a question? I'll take a pause here and I'll ask a question here. Like, where is forecasting useful to us? Anyone can answer? Where is forecasting is used in our day-to-day lives? Okay, all right. Yeah, let me answer this question. So forecasting is
actually when I just want to, go to office. Before that, I just want to have a check whether this is rainy or sunny. So sometimes I use. So when I feel that it's raining.
Excellent. Weather forecasting, right? So yeah. And where else you would have, you wanted to become richer tomorrow. You wanted to become richer tomorrow. So how do you become richer tomorrow? You wanted to invest in stock markets.
Yes.
Right? You wanted to invest money in stock markets and become richer tomorrow. So you wanted to do that forecasting, right? So how you we will study about this forecasting. We'll do a deep mathematical analysis on forecasting and what is time series data. So the important variable in forecasting is, what is the important variable here? Time. Time is the variable which is extremely important in time series forecasting, right? So we will do a deep analysis on time series data and time as a variable, and the rest of the other variables we will do a deep analysis. Now, you must have a question to the audience here. What is forecast? How is forecast different from prediction? Are they alike? Are they different? Are they same, similar, different?
Somewhat same.
Okay. Okay.
Maybe forecasting depends on data, I think. Prediction, I'm not sure.
Okay. Okay. Good. It depends on data. Yeah. Forecasting and predictions, they depend on data. All right. So forecasting depends on a data that is available over a period of time, like 1 month or 1 month. Right? You wanted to do a weather forecasts are always available over a range of time. But prediction you do at a specific time interval. I wanted to predict whether it will rain now or not, or at 7 p.m. Will it rain at 7 p.m.? At 7 p.m. Over a time period. Over a time period is forecasting, right? You wanted to see the forecasting for the next week. you wanted to check the weather forecast for the next 1 week, right? To see the weather forecasting for the next week, you will open your app and then see on which days it will rain, right? And then you wanted to see at 7 p.m. will it rain or not. So at 7 p.m. you need the prediction at 7 p.m. So prediction is at that particular instant, and the weather forecast is over a specific time period, right? Hope I'm clear with this, right? So, so okay, so time series forecasting is usually done in is usually it's dichotomy. It has a dichotomy. When I say dichotomy, it is you do it. It has cyclical patterns, right? It will have cyclical patterns.
Vijay, can you just make me as a host for a minute, and I'll make you as a co-host. There are some people who are waiting. We are not able to. I think there will be some people admit. You can also admit them if you accept it. Actually,
how do I do this?
The right hand side in the participant, you will get somebody waiting actually. Okay. Otherwise, you can make me as a host, and then I will again make you as a co-host.
Okay.
You have to right click.
How do I make you as a...
Click on more. On the participants thing, on the participant list, you will see your name, right? And at the right hand side, you will see more. You click on that.
Okay.
And then you can make me as host.
Okay. CTMS, is it?
Yes, CTMS. Yes.
Okay. Okay.
Okay, now I make you as co-host. Okay, now you can continue. Yeah.
Okay, sure. I think there's one more person who is waiting here. I think I've admitted him.
Yeah, I will take care of now actually. Yeah.
Okay, good. All right. So yeah. So so we have been talking about some of the applications of data sciences. We spoke about monsoon prediction. We spoke about clustering. Why clustering is important. This is to make products based on what users would need, and then we have seen example here. And then now we will speak about time series forecasting. So time series forecasting is usually you will have trend here, trend and cyclical. Time series analysis is typically it will have trend over a time period, and then it will also have, so this is trend, this is what you call as trend, and this is cyclic nature. This is cyclic nature of data. So if you look at the sales data, right? If you look at the sales data of an organization, right? In the say for example, mango sales. So mangoes sales would pick up in the month of June, right? And back in the month of, it comes down, the demand comes down for the mango and the sales goes up, right? So this is how the cyclical nature of sales, if you look at, so this is how the cyclical nature of mango sales, if you look at, if you look for say fruity, right? Whatever, you have many manufacturers, that sell mango related products, right? So mango products, sale of mangoes would peak in the month of May, in the month of June, and dips in the month of December, and again picks up in the month of June, and again dips in the month of December. So this is how the data would cyclically vary when you do a time series analysis. When you plot the time series of when you plot the sales of mango with time, with year, or with month on month analysis, right? So there is trend and as well as cyclic. There is trend as well as cyclical nature to the data. right? So we will talk about this, what is trend and what is cyclical when we talk about time series forecasting. So this is a very interesting topic. We will look at different techniques such as ARIMA. ARIMA is one of the machine learning techniques that is used for time series analysis. And then there is also a classical modeling that we also discuss about when we talk about time series analysis. So time series analysis is something where so to summarize, time series analysis has a variable called time, and there are other parameters which vary, such as profit, sales, number of customers. So they would vary with time, right? So we will see how to do mathematical analysis for time series data, and then we will do a lab for time series data using Python, right? Yeah, so let's talk, that is about time series data, and let's move on and talk about other applications of time series, other applications of data sciences, right? So, so this is how time series data would look like. And then you wanted to, given your time series data, right? Given your time series data, you wanted to predict what will happen next in the next 1 week, in the next 1 month. You wanted to predict how your shares are doing next week, how your shares are doing next 1 month, how much profit am I going to earn next quarter, right? If you wanted to do this prediction, right? So we use time series analysis. If you wanted to do forecasting and prediction, we will use time series forecasting, and we have seen like ARIMA is one of the methods we typically employed for time series modeling, right? So let's talk about next. Let's talk about next application of data sciences. So we use data sciences in fraud detection. This is a very exciting area and a very important and lucrative domain for data sciences. So if you have domain knowledge on insurances, on insurance claims, or any financial products, right? Like if you're a banker, or if you are an insurance agent, or if you are if you are a guy from a strong strong insurance background, and if you have knowledge of statistics and data sciences, then this is an extremely lucrative area for data sciences, believe me. So why and how do you use data sciences in these domains? So one of the important is claims fraud. What is claims fraud? So claims fraud is you underreport age, and then try to try to buy a policy with lower premium. So how do you detect the claim fraud here, right? And then somebody who has done a criminal activity, somebody who has reported a crime, who was involved in a crime, and then he wants to make a false claim here, and then bring loss to an organization. So how do you detect those crimes? So these crimes are like extremely sparse in the data. It's like finding a needle in a haystack, right? So how do you detect such crimes? You have millions of transactions happening every day, and then you wanted to detect a fraudulent transaction. So we use machine learning techniques here, and it is essentially called outlier analysis in machine learning. So we will talk about a few important machine learning algorithms here, such as support vector machines here. Support vector machines are extremely useful here for fraud detection. And there are also other techniques like decision trees. We use decision trees like CART. We call them as CART, classification and regression trees, or these are the decision trees we use for fraud detection. We will talk about these machine learning models, we will talk about the mathematical analysis of support vector machines, and then we will see a Python implementation of support vector machines and decision trees for this specific application. We will do a Python lab for this. Right. So the other, the other application in financial frauds is about anti-money laundering. So why anti-money laundering? Why now anti-money laundering? If you would have noticed, the biggest problem now is terror financing, right? So money, ill-gotten money from different channels is sent to terror organizations to spread terror, right? So how is that ill-gotten money? Where is that ill-gotten money coming from? Through anti-money laundering channels, through banking anti-money laundering channels. So how do you arrest such anti-money laundering channels? So anti-money laundering channels are like suspicious transactions. You have to identify what transactions are suspicious. So suspicious transaction reports that come from banking organizations are used to filter out transactions that are extremely suspicious transactions are extremely sparse. So if you look at banking transactions, right? Banking transactions happens in millions, right? And then suspicious transactions are just 0.001% of these transactions are suspicious transactions, which means out of 1 million, out of 1 lakh transactions, you will see one such transaction which is suspicious. Now you have to find the patterns of those suspicious transactions. You have to see the patterns to collect the patterns of the suspicious transactions, right? So how do you do that? We typically use something known as association rule mining. Association rule mining is one of the techniques that we will study to establish the relationship between the persons, organizations, and the date and the money. There are a set of rules, and we will study those rules. So we'll do a short POC on anti-money laundering and the credit card fraud to identify how these variables are interrelated. We will see we will do a plotting. We will do a graphical analysis between between variables such as customers, organizations, and their ill-gotten money, right? So we will do a deep analysis on using association rule mining, doing a graphical analysis between these variables, and then try to ascertain which of the transactions are suspicious transactions. And if there is a new transaction, we will learn those patterns. After learning those patterns, and then we will see if there are any new patterns in the data which talks about suspicious patterns, which has suspicious transactions, right? So this is a very important application that we will do a deep analysis on. And yeah. The other area that I wanted to talk about today is on. So far we have been talking about data, tabular data, right? So far, now So we have been talking about tabular data. Now we will talk about some data which is not tabular data, the textual data. So textual data, such as reviews from customers, right? Reviews from customers, or product descriptions. Reviews from customers and reviews from product descriptions, right? So this is all textual data. Now, how do you process the textual data? Textual data is extremely unclean. Reviews are extremely unclean. How do you clean them? So we will see. We will do a short POC for textual analysis. We will see a short POC on textual analysis, and then we will see. If you look at if you would have bought something on Amazon, right? You would have something seen frequently bought together, or products similar. So how is Amazon trying to show you that, trying to understand that what are you purchasing? when you are buying a book on data sciences, it will recommend you many other books which are related to data sciences, right? So how is it recommending books related to data sciences? So it does, what it does is it looks at the description of, it looks at what you have searched. You have searched for data sciences books, right? So it looks at those categories of data sciences. It looks at similar books, and it looks at similar prices in which this book is book you have selected. Using that as a criterion, it does search within this database to identify what are those similar other similar books which it can recommend. So those are called recommender systems, right? So we will talk about recommender systems in NLP when we are not studying NLP here, but this is one of the extremely important application, recommendation systems. There are many recommendation systems that use that uses something like cosine similarity, that uses word mover distances, that uses Levenshtein's distance, right? There are many machine learning models that we study as part of NLP. Since NLP is out of course, but I'll give you a brief understanding like what a recommendation system is. So it uses cosine similarity of vectors to identify which two vectors are identical based on the text, based on their text. So we do the text vectorization, we do lemmatization, stemming. There are a whole lot of process steps which we do as part of recommendation systems. And further down the lane, then we do querying here. So if you would like to understand more about this, probably you can register for, you can look at the NLP contents for, you can look at the NLP certification contents, which is available on our website. So we'll talk much lesser about the text analytics here, but this is one of the areas where recommendation systems and ARM is typically used. Right, so let's move on and talk about the other application. Text prediction, right? So text prediction is another example. So if you have looked at your Gmail, right? So your Gmail has a filter here. So, and this filter has a set of emails which you are not interested in. So how are these systems built? How are these systems classifying emails as inbox emails, archived emails, and junk emails and draft emails, right? How are they? What is the intelligence in your email systems built into? So there is something known as text classification that we typically use for text, for text classification. There's also something you would also seen about text prediction, right? So most of you would have Gmail accounts, and when you do a compose, when you write an email, right? So the email's name, so the sender's name automatically populates here in gray, and when you click a tab or when you click a next, probably it will tell you what it would be. And when you compose your email, right, it will tell you what the next word would be. So how are the systems so intelligent that they are predicting the next words? So so these systems have something known as NLP intelligence, natural language processing intelligence, built into. We will talk about more about this NLP intelligence when somebody when somebody subscribes for NLP certification, right? So this is a very important and exciting area. And object detection, right? So object detection is object detection is detecting what kind of object this is, whether this is a lamp or a person or doing a behavioral analysis here. So how is this happening here? How is this happening here? How is if somebody is involving in theft, right? So the theft is a behavioral pattern, right? So how is the theft identified? How is that theft identified from the data? So you use some of the techniques using computer vision and deep learning and computer vision techniques for behavioral tracking and object detection. So this is not part of the machine learning course, but this is one of the exciting areas where significant study and development is happening in this area. So that is, object detection is one of the areas. And the recent example is, I can give you, is China. China has used object detection and behavioral techniques to contain the spread of COVID-19. Right. So I would encourage you to go and study about how China has implemented machine learning and deep learning techniques in object detection and in the implementation of COVID-19. So this is one of the exciting areas. The other area where object detection comes handy is criminology. Right. So detecting a person's face and then identifying his behavior. So you can derive the patterns. And as well as you can identify whether a person has any criminal background. So you can make those analysis. You can develop intelligence systems and then make analysis, and then you can reduce the crime. In a specific country which has implemented machine learning. Right. So yeah, this is some of the applications of data sciences. So we will be talking about these areas, which are which is about this area is called classical machine learning, and we'll talk about machine learning, and these areas are related to NLP and computer vision. This is not covered in our subject. So these are the we will look at all these use cases as we study. So I'll take a pause here. If you have any questions, probably I can take. Hello. I'll take a pause here. If there are any questions, I can answer.
So we can find out these algorithms for our case studies. If I took e-learning, means which algorithm shall I use for that? It will be useful.
For e-learning, is it?
Yeah, e-learning. If I take a case study for a questionnaire analysis for e-learning in the COVID-19 situation, means which method I can choose? Is that a clustering or?
What is the problem that you wanted to study here? So the machine learning algorithm depends upon the problem that you wanted to solve. E-learning, right? So what is the problem here in e-learning?
Yes, impact of e-learning.
What is the problem here? What is the problem that you wanted to solve?
If the age of students under 10 means they find difficult to analyze online classes, right? They are facing some difficulties.
Okay. Okay. So e-learning problem. The problem you wanted to solve the problem of e-learning by the students, right?
Yeah, for under age 10 group students.
Under age 10 group students.
Yeah.
Right. So under age 10 group students, you have a set of under age 10 group students. They wanted to they have a problem with e-learning.
Yeah.
So first you have to do to solve this problem. First you have to do unsupervised clustering, like you have to cluster the data, what kind of problems they are suffering from. Many of them do not have gadgets. Some of them are computer illiterates. Some of them are which age groups of these people are which age groups of these these students have problems. So you have to you have to use a unsupervised learning initially, and then you have to do something like univariate analysis and bivariate analysis. First of all, you have to get the data first of all.
Yes.
The important part is collecting data is very important, and this is always the most toughest part for a data scientist. So after you collect the data, you have to get into the analysis, or to get into univariate and bivariate analysis, and then you have to get into analysis of each variable. So it's so unsupervised learning techniques are pretty much enough for this kind of a problem. So you would use something known as clustering here.
Yes.
Right. So you would use clustering techniques.
Thank you.
Yeah, you're welcome. All right. So so we'll move on, and then we'll see the next application is about language and text translation. So this is another area where significant significant research and development is happening with respect to NLP, language and text translation. So you speak in English, and then a system is developed to convert this into a language of your choice: Tamil, English, Telugu. You speak it in Spanish. You send your speech data to a system which can understand Spanish, and then a machine learning model translates this Spanish to English, Tamil, and Telugu. So this is known as a language translation system, where significant research is on. Right. So the next application is text translation. So you would have seen that in Google Translate, you type in English, and then you select a language that you wanted to translate. It translates English to Tamil, right? So how are these systems so intelligent that they are doing the translation here? They are converting languages from one language to another language. So how are these systems? What is built? What is the intelligence built into this? So the intelligence is the NLP intelligence, and there are something we use something known as deep encoders, decoders. We use deep learning techniques such as encoders and decoders to convert one language to another language. An encoder converts a series of text, encodes the series of text into a vector, and then a decoder understands the decodes the encoded language and converts it into whatever it has understood based on what it was trained prior to that. So based on that, it decodes it into a different language. So this we will study this deep learning text translation systems in deep learning when we study about deep learning. So this is a different certification course where this is a different certification course. So these are some of the examples or applications. There are many other applications, many areas. Every area has its own application, right? So these are some of the areas where machine learning is applied, right? So that concludes about machine learning, applications of machine learning. Now you can come up with your own examples in your organization, in healthcare, in banking, space tech, in sports, retail, income tax, railways, politics, police. So these are the different domains where machine learning is actively being applied. Space tech is extremely lucrative job. A data scientist in space tech domain, most highly paid. Data scientists here are highly paid. Now, income tax, you would have seen autofilling. You would have seen a PDF converting to a Form 16, right? So how does a PDF converts into a Form 16? How does a Form 16 converts into a PDF? All your banking. So if you would have looked at the Form 16 document, they would have, a Form 16 would ask you to fill your banking related information, right? So as soon as you fill your banking, bank name and account number and IFSC code, so what they do is they convert all the transactions, all the incoming transactions and outgoing transactions. They would do the classification. They would classify which transactions are revenue-based transactions, which transactions are expenditure-based transactions, and based on the based on your banking data, they would create a Form 16. Now you don't need to create a Form 16. They would develop a Form 16. So you in future they would not be there would be very less number of employees working as a in the income tax department. No, almost about 50% of the offices have closed, and many of them were sent on VRS or were sent or either to be upgraded, right? So it increases revenue significantly. Machine learning increases revenues of government revenues significantly. It also increases in transaction transparency. It reduces in the reduction of black money, and convert as many white transactions as possible. So defense. So defense is another important area where machine learning is used, but you have your own set of scientists for the defense sector. Politics, right? What is the other application that you can? Where do you use machine learning in politics? To bias customers, to bias voters, right? That is how machine learning is being used to bias the thinking of customers now, to bias the thinking of voters now. So how do you bias the thinking of voters? Through fake information, fake videos, fake news articles. You use these fake information and then create a bias in thinking of a voter. Now, if you would have seen if you would have seen WhatsApp forwards, right? Many of the videos in WhatsApp forwards are fake. They claim to be true, but they are fake. And then as a result, it has created a bias in the thinking of a person that it is very difficult for a human being to judge what is true and what is false, right? So fake information, elimination of fake information is one of the very active areas where machine learning is being used. Hello, there's a question there. Hello. Is there a question there? Can you unmute? Hello. Can you please unmute if you're not using your mic? Hello. Right. Yeah. So politics. In politics, like soon after voters have completed voting, right? So political parties are interested to know who will win, right? So how do you know who will win tomorrow? How do you do the prediction? We use statistical machine learning models to do the prediction. We will see one example here for politics about winning percentages of one political party against the other. We will do a short example here for this as you learn how you implement machine learning for politics. This is one of the interesting areas. All right, so these are the different areas where machine learning is used predominantly. All right, so I'll take a pause here, and then if there are any questions, probably If anyone has any questions, probably any applications in your organization, probably you wanted to discuss, we can see how data sciences can be applied in your organization for improving the productivity of your employees. HR? If no questions, we will move ahead. If you have any questions we wanted to discuss, I'll just take a pause and then see what kind of applications that you have in your organizations where machine learning can be applied. You can speak up, there is nothing right or wrong, you can speak anything that you wanted to share.
So you told bias. What does that mean? Bias means mods.
Excellent. Okay. So bias is, if something is, this is an unbiased state, right? Now, when you wanted to create a bias, right? Something like you wanted to change the thinking of people. Say you have an opinion, say COVID-19. You look at fake videos. Spreading fake information about COVID-19, like miracle cures. Miracle cure is information about miracle cures about COVID-19 makes your mind biased, and then tries to forces a person to lean and apply fake cures for COVID-19. So so fake news is biasing your mind. You are not able to judge whether something is true or not. So that is a biased state, right? So, and what elections, during the elections, right? During the elections, you would see lot of videos from politically motivated videos. You would have seen several politically motivated videos, denigrating or making mockery of one political party about the other. So that creates a bias in your mind. And then you fail to judge whether you still remain in that biased state unless you have very relevant truth that takes you to a true thinking. For example, let me tell you, I don't know if I had to give you this, if you, during the COVID-19, right? During the initial periods of COVID-19, you would have noticed some videos, politically motivated videos towards a specific religion. So that would have created a biased thinking about a specific religion, and then you would permanently change your opinion about them. So that is bias, right? So using fake information about an event, you're using a fake information about a series of events, and then trying to modify the thinking of people is called bias, inserting bias. So we will talk about this bias in data bias. So some people will, what happens is, when you have surveyors coming to your home, when you have data collectors or surveyors coming to your home, some people would give deliberately wrong information. They would create bias into the data. Like when data collectors come to your home asking about your name, your age, number of people working, and then the age of, and then the salary, what people would do is they would deliberately give wrong information. Deliberately giving wrong information is bias. right? So once bias enters into the data, it becomes it tilts the opinion. It reduces the prediction capability of the algorithms. So it is important that you have to apply statistical techniques to eliminate bias from the variables. So we will see this as we talk about as we do a deeper mathematical analysis about how to remove bias, how to use Python to eliminate bias. So we will see this. We'll use different examples, and then as we learn more about as we talk about data, we will explain about these things. All right.
Thank you, sir.
You're welcome. Yeah. Okay. So what is data sciences? Let's talk about what is data sciences. So data sciences, there are many terms that are going on in the market. Some say data sciences is machine learning, and some say data sciences is data mining, and some also say data sciences is also big data analytics, and some say data sciences is also deep learning. So it is so these are the different terms synonymously used for data sciences, but data sciences is all of this. Data sciences is all of this. It encompasses all these areas. So machine learning talks about algorithm design, which like we use supervised machine learning techniques, unsupervised machine learning techniques, reinforced machine learning, reinforced learning. We also talk about transfer learning. There are many algorithms in these areas. So machine learning talks about design of algorithms and development of the algorithm. Design and development of the algorithm as machine learning, and evaluation of the machine learning algorithm using different data sets is machine learning. So machine learning is a sub area of a data science. And data mining. So data mining is also synonymously used with data sciences. Now, what data mining is about is extraction of data from the backend systems and managing the data in the backend systems, managing the data in big data systems is data mining. Data mining is about extracting the data, managing the data, and analyzing the structured data and analyzing unstructured data. Now, do you know what is structured data? Anybody?
Is text.
Structured data is data in the databases.
Text.
Unstructured data is text, right? Unstructured data is textual data, which does not have a structure, and speech data from speech systems, and data from images related data is also unstructured data, and data related to videos is also unstructured data, right? So analysis of any of these data from database tables, tabular data is something, the structured data is also called tabular data, right? So analysis of structured data, analysis of tabular data is data mining. Extraction of data from the backend systems is data mining, right? So these are the different different names that we give for data sciences, but data sciences encompasses all of them. And deep learning, right? So deep learning is about study of neural networks. We study neural networks, which so deep learning is about neural networks, and neural networks is an area where neuron and brain cells and neurons are used. Brain cells and neurons are used. They have been simulated. Brain, the way neurons have been structured in a brain to take decisions, right? So we have used neural networks to simulate the brain, to simulate the structure of neurons to take decisions. So that kind of a study is deep learning, and data science also encompasses deep learning. So there are several architectures, deep learning architectures, like feed-forward neural networks, which also use backpropagation, convolution neural networks, recurrent neural networks, LSTMs, long short-term memories, and then we have GRUs, gradient recurrent units. There are several architectures, encoders and decoders. There are about at least 50 to 60 different architectures, deep learning architectures, which is a different field of study, but they also are part of data sciences. And we use deep neural networks for structured data as well as unstructured data, but seldom we use for structured data. So we rarely use deep learning for structured data, but majority of the unstructured systems are deep learning based systems. Right. So this is about the synonyms of data sciences. So talking about data sciences now, data sciences is about in data sciences, what we do is we use statistical tools. So far, we have seen that we have seen different applications. Now, in data sciences, what is that we do is we use statistical tools to extract data and manipulate data. Statistical tools like Talent, R, Python, Julia. So we use statistical tools, MATLAB. We use these tools to perform ETL, big data, to convert, to bring the data from backend systems to analytical, from OTP systems, OLTP systems. OLTP systems are online transaction processing systems. We bring the data to OLAP systems, online analytical processing systems. From OLAP systems, we bring the data again to do machine learning, to develop machine learning models into our local systems or into big data systems to perform mathematical analysis. So we'll talk about that. So we can also bring data from web pages, right? We have web pages. We can scrape the web pages and then perform mathematical analysis. So statistical tools such as Talent is ETL tool that we use to bring the data for to develop a machine learning model. We use Scrapy to extract data from web pages. We use SQL to bring the data from databases, from backend databases, to perform to develop a mathematical model. And we use text or CV systems, text or CSV data from backend systems, from sensors, right? We bring data from sensors to develop mathematical, to develop a machine learning model. So essentially, data sciences is about study of statistical tools for extracting, manipulating data, right? And after you bring the data into machine learning model development, what we do is we will have to work on the data. We have to clean the data and transform the data into a numeric form, right? So there are a set of steps that we typically use for converting data into a numeric format. So this is normalization and standardization is one of the techniques that we do. So we use statistical data to bring the data into a machine learning system. After the data comes into a machine learning local system, what we do is we perform a cleaning on the data. Now, this is a tabular data. Now, is this data cleaner? Is this data clean? This is an example of how tabular data would look like. Now, a question to audience here: is this data clean?
No, it's the combination of text and numeric values.
Yeah, it's unclean data, right? You have NaNs here. NaN stands for not a number. Yeah, not a number. NaN stands for not a number. You have NaNs here. NaNs is you have numeric data here, and then you have NaNs here. So this is unclean data, right? And then you have NAs, not a number, right? So you have you have data in, you have textual data, and then you have numeric data, right? And then you have textual data, and then you have NaNs here. And then you have numeric data, and then NaNs as well as textual data, right? If you, similarly, you have NaNs and then numeric data, right? So this data is unclean. So how do you clean this data? So to clean this data, there are a few set of steps, like you have to import this data into a Python environment. So Python environment. So using statistical tools, we bring the data into Python working environment. And then we perform cleaning exercise on the data. We have to clean the NaNs. We have to, most of the times, right, the data that comes from databases are from multiple databases. So you have to merge data from multiple databases. So you have to perform that analysis beforehand. So data scientists would sit with data engineers and data analysts to understand which data to be picked and which data from different databases to be picked. So data scientists would do this analysis beforehand, merging the databases from multiple database systems. After bringing the data from multiple databases, data scientists would work together to remove the missing data. So there is a strategy that we will discuss during the course, how to remove these missing values. So there is a strategy. There is a 3-hour session planned for removing the missing values. What strategies do you have to employ? And then after you remove the NaNs, what are you going to do with this data here? You have the data in textual format, right? You have the data in textual format here. So how do you convert this textual data? How do you standardize this data? How do you normalize this data? So we will do a deep analysis. We will do a mathematical analysis. Also, we will also use a Python lab. We have a Python lab to convert this kind of data into a numeric format. That is, so always data must be in numeric format for your machine learning model to understand it. So that is why we use normalization techniques and standardization techniques. Now, if there are any outliers, what are you going to do? So we'll talk about outliers as well. Outliers are that data where say in a class, in a room, you have about 100 people sitting together, right? You have 100 people sitting in a room, and they are discussing about their salaries. And then you have an employee who is earning about 5,000 per month, right? 5,000 per month. And then you have an employee, and then you have Bill Gates sitting in the room. And then government employees sitting in the room, right? So now, who is an outlier here? Outlier is definitely Bill Gates, because salary of Bill Gates is it's equal to the economy of a small country, right? So Bill Gates, when you talk about the salaries, he is definitely an outlier. So how do you identify outliers? What are the statistical techniques that we have to identify outliers? We will do a deep mathematical analysis on different tabular data to identify to do what kind of machine learning models that you have to use for to eliminate outliers, and then how to treat the outliers. We will do some analysis on that. Okay, we will study that. So so just to be clear, we have spoken about so data science is about statistical tools, and then used for transforming, for cleaning data. And then data science is also about learning patterns, right? So you have to uncover patterns. So that is why we use machine learning techniques. Machine learning techniques are the ones which uncover patterns. So how does patterns look like? Patterns look like this. When you use Python, to excavate patterns, to explore patterns, to understand patterns. So when you apply different visualization techniques, you will be able to uncover patterns. You will be a data scientist should be able to tell a story based on the patterns identified from each of the variables. So data scientists would do univariate analysis, multivariate analysis to tell about a story about what the data is telling about. And then data sciences is also about storing about big data systems. So data sciences is also about big data systems. Many a time, what is this is big data systems is also like you have data. Now you have data. So data is coming. Data sits in a big data database here, like S3, right? So now huge data. This is a data lakes of trillions of bytes, TBs and zettabytes of data sits in Hadoop clusters, right? So these data has to be processed. Now you can't process if you wanted to process zettabytes of system on your laptop, right? Would you be able to do that? You would not be able to do that, right? You cannot build a machine learning model for zettabytes of data. You cannot have a RAM with zettabytes of, you can't have a 1 zettabyte RAM, right? To perform your machine learning model, to train your machine learning model. So what are you going to do? So to do that, we have something, we have to train this machine learning models on a distributed cloud computing system, such as AWS, such as GCP, Google Cloud Platform. So how do you do that? So data sciences is about this storage and processing of big data. So data sciences is about statistical tools, cleaning of data, uncovering patterns, and exploring and storing the data and processing the big data from the big data systems. Right? And big data is also about machine learning algorithms. So we know we have big data data sciences is about different types of algorithms: classification, regression, dimensionality reduction. We'll talk about all of these algorithms in our in the next 6 months. We will be talking about all of these algorithms, and we will be mastering all of these algorithms. And then big data sciences is also about data ethics and privacy, right? Data protection, ethics, and privacy. So you have to respect privacy. So data ethics and privacy is the prime reason why the data in the healthcare systems and financial domains it is extremely difficult to get this data from these systems, but you have to respect privacy. You can't use machine learning for that erodes privacy of an individual, right? So you have so a data scientist should be very careful with the data that you handle. So we typically work on public data sets majority of the time, but private data is something which should be handled with extreme care. Otherwise, data scientists would lose their jobs. There are many folks who have lost their jobs as a result of data security and privacy concerns. So a bit of caution there, a word of caution there, right? So what are the areas of focus now? So we have spoken about applications. We've spoken about what data scientists would do. Now, what is that a data scientist should have? Should have domain expertise. Domain expertise must be somebody who is from, if a person who is from financial background, it works very well for him. Or if he's from a healthcare domain, it works well for him. Or if he's from a government sector, it works well for him, right? So a domain expert should also have very good communication skills. Like a data scientist should be able to explain a story from the data, right? And then he should be having strong data wrangling. He should do a data wrangling, exceptional data wrangling techniques. He should be aware of all those techniques, and he should be conversant with databases, MySQL, Oracle, he should be conversant with the databases, and who knows, who is very good in statistics and applied mathematics, and who knows Python for data visualization, and who can who can tell a story using these tools, Python, R, and Julia. Who knows about machine learning models, who learns machine learning models, and then who has information about data ethics and regulation, and somebody who knows about cloud computing techniques. Now of these, what are important? What are the important ones to have? Communication skills are these are must-haves for a data scientist, right? SQL querying, applied mathematics, statistics, probability theory, machine learning, Python programming, R programming, or Julia or MATLAB, some of the programming languages. Data analysis and ethics are must-haves for a data scientist. And good to have is somebody who has good knowledge on cloud computing and big data analytical tools such as Hive or AWS or GCP. So, it's good to have that, but a data scientist, but these are must to have ones. All right, so we spoke about applications, right? We spoke about what is needed for a data scientist to excel, and then we will see what is designed for in the course content, right? So right, so these are the contents of the course. We will talk about we'll discuss about Python. We'll do a deep analysis on Python for 2 to 3 weeks, and then we'll do EDA. We learn about how to do we learn how to perform, how to clean up the data, right? So we'll do a EDA on the data. We'll try to understand how to do univariate analysis, bivariate analysis, analysis of variance. So these are some of the techniques that we will learn as part of the course, and then we will study about statistics, and we'll study about types of sampling. So we will talk about statistics, talk about probability theory, discrete probability theory, continuous probability theory, different types of techniques that are available in inferential statistics, right? So we will talk about it for about 2 to 3 weeks here. So this is a very important area, statistics and inferential statistics. This provides the fundamental background for the student. And then once you have the fundamentals stronger, we will do some case studies here. As we learn and explore these areas mathematically, we will do case studies as and when they are needed. For each of these modules, we'll take some of the available some of the examples available in the industry, and then we will try to solve those examples, learn those examples, and then we'll talk about unsupervised learning techniques for continuous variables, for categorical variables. We'll do a deep mathematical analysis using Python. We'll talk about clustering theory here for k-means. We'll talk about KNN, k nearest neighbors also. We also do a k-means. In addition to k-means, we also learn about k.
Vijay, you want to show other than this Python programming, data analytics, we are not seeing anything.
Is it?
Yeah.
Okay. Maybe I'm not. Sorry, I'm really sorry. I'm really sorry. I think I have not shared the complete screen here. I'm sorry. How do I do that? How do I do this? How do I do this? Okay. Is my screen visible now?
Yes. Yeah.
Okay. Excellent. Sorry about that. So yeah. So I was talking about I was talking about Python, what we learn as part of these course curriculum. We will do, we'll study about how to clean up the data. We'll do the, we'll see how to clean up the data. We will also talk about inferential statistics, types of samplings. So we'll study about types of samplings. We'll do a deep study on statistics, how to use statistics in machine learning. What are the different attributes? When do you say that your data is clean? When do you, at what point of, how do you, to which layers of data that you have to work on? You can't work on all data at once, right? You have to layer your data. So how do you sample your data? You can't use your zettabytes of data at once for an analysis. So what you have to do is you have to take samples of your data. So how do you perform those samplings? What are the different techniques available in sampling of data? So we'll study about them. And then we'll study about different techniques, statistical techniques, like we'll do a hypothesis testing. How do you create an experiment? We will study about that. And we'll study about null hypothesis and alternate hypothesis. These are the techniques that you use for experimentation. Once you establish a hypothesis, so you wanted to perform whether your experiment is true or false. So how do you decide on that? We'll talk about that. We'll do the A/B testing. That I'll tell you an example for A/B testing. Is, say you wanted to have a add to cart in a web page. You wanted to have you wanted to design a button. Now, for your button, for the design button, now you wanted to name it as add to cart or buy. So how do you decide this? So we will have to use A/B testing. We will do the A/B testing. We'll take some examples here and do the A/B testing here. And then we'll study about t-distributions and chi-square distributions here. We'll talk about them mathematically, how they are, what is the significance of these tools in machine learning. So once fundamentals are built, we will talk about different techniques such as unsupervised learning techniques such as PCA used for continuous variables, k-means and k-mod, k-median, k-medoids used for categorical variables. We'll use some of these techniques here. We'll do a mathematical analysis and then do a Python lab for these machine learning techniques. We'll also study about hierarchical clustering. We'll do a mathematical analysis on that. And then we'll study about supervised machine learning. This is an extremely important area that you should never miss it. We will do a deep mathematical analysis of every single algorithm, every single technique, for regression techniques, for classification techniques. We'll do a mathematical analysis. Once you have a mathematical understanding, we go and develop we take an example, and then we do a short project for every machine learning algorithm that we have learned. Right, so we will do this as soon as we are done with the unsupervised with the machine learning models. We will go into a deeper machine learning models, which are not taught by many organizations, but these are extremely important areas. Like, how do you build a sophisticated advanced machine learning model? We do a mathematical analysis of these machine learning models, and then we do a lab. We'll do a lab. All right, so we'll study about one of the industry. We'll study about the industry grade extreme machine learning model known as XGBoost, which stands for extreme gradient boosting. We'll learn about the theory. We'll do a mathematical analysis of XGBoost, where we will take the research paper and then solve the research paper and then do a lab for XGBoost. So this is this machine learning model is used in Kaggle and many other competitions to win competitions. Like, so that is why we will learn XGBoost little elaborately, and then we'll talk about the time series modeling, and then we'll do a very high level study about what are neural networks and how do you we'll do a mathematical analysis of neural networks, and then we'll take a case study, and then we'll conclude our session there, right? All right. So let's go back. So that's the content of this course. We'll talk about, we will do data analytics using Python programming, and then we'll also do data analytics using, we'll study about these ones, right? And then statistics, we'll study about these areas. We'll study about parametric machine learning models and non-parametric machine learning models. We'll talk about this when we talk about machine learning. All right, so that is the first, that's about like what we will be having. What is, so we've spoken about applications of, data sciences, and what is data sciences and what we will study as part of data sciences. So probably if you want to take a break for 5 or 10 minutes and have any questions, probably, yeah.